I love work. Really, I can sit and watch it all day. We invite you to watch work on a geothermal system installation. It's not the type that powers entire cities. This is a unique heating and cooling retrofit of a single building housing a 733-seat auditorium. Welcome to Geothermal Debuts Norwood Theater. A geothermal system uses ground heat captured by water in the winter and pumps it indoors, transferring it throughout a building. The system reverses itself in the summer, pulling heat from the building, replacing it into the ground. According to RenewableEnergyWorld.com, geothermal can produce between 50 and 80% lower heating and cooling costs for a building, perhaps the size of your home, over the next 30 years. Question: of the three energy use sectors in the USA, transportation, industry, or buildings, which one emits the most CO2? Answer: our buildings. Yes, our homes and workplaces emit the largest amount of CO2. Astoundingly, that is more than all the cars, buses, and trucks on our highways, and also the industries we use. At present, our buildings and homes emit 40% of all greenhouse gases in the USA. In changing this, we invite you to watch as practitioners of modern technology are creating a money-saving, pollution-free, safe as a refrigerator, heating and cooling system using the boundless energy found everywhere within 6 feet underground. Indeed, the amount of geothermal energy potentially available is, in the words of U.S. Secretary of Energy Steven Chu, effectively unlimited. Geothermal for buildings can play a role, if not the significant renewable energy role, in the United States. Watch these quiet, competent, efficient professionals perform in the exceptional manner of their grandparents and great-grandparents of the early 40s who in 6 months turned the entire American industrial economy into a stupendous fascist fighting continuum of material resistance. That everyday work environment spirit is readily apparent in this building organization as they toil on the right side of history. This competent organization could very well be a precedent-setting story of how to put American exceptionalism in the driver's seat of a convoy delivering our badly needed economic recovery from sea to shining sea. Their effort today is the production of methods for transferring ground heat inside to create a comfortable environment using electrical pumps and no fossil fuel. It's a unique chronicle of a geo-exchange or ground exchange of heat. By the way, it's also a climate control retrofit of an 85-year-old theater within a limited urban space. The modern heat pump used here as the heart of the system acts like an air conditioner and refrigerators. When a gas is quickly compressed, its temperature rises. Also, when a gas is allowed to suddenly expand, its temperature falls. In the winter, the heat from the compressor at 130 degrees is transferred throughout the building by air ducts and/or water pipes, allowing fossil fuel-free heat. The heat pump has switches, and by using the cool expanding side of the compressor during the summer, the cool 65-degree feed is transferred throughout the building by the same air ducts or water pipes. Unlike window air conditioners, which are using 90 degrees air to cool the compressed 130 degrees air, heat pumps use ground source 55-degree water to cool 130 degree air, which is more efficient with less compressor pumping. Geothermal Debuts Norwood Theater is a behind-the-scenes look at an all-star cast of professional tradesmen, builders, and engineers as they integrate, organize, and construct a geothermal or geo-exchange HVAC, that's a heating, ventilation, and air conditioning system. For this debut, we have gathered some members of the crew who explain in their own words some background and challenges experienced during production. What follows is a personal account by a number of these professionals who created this exciting, flawless debut. No matter what your product, Planning is the initial and essential part for success. Here is Tim Ruse, the first of our superb team, the blueprint planner creator, explaining some of his responsibility and involvement.
My name is Tim Ruse. I'm a professional engineer and certified geo-exchange designer. I have a wonderful wife, Julie, and 2 teenage children, Jacob and Bethany. I grew up just north of Boston and Burlington and currently live in southern New Hampshire. I am the founder and president of Wellspring Geothermal. My company has the sole focus of designing and overseeing the installation of geothermal-based heating and cooling systems. Therefore, the geothermal aspect of the Norwood Theater retrofit project is not new to me. I have been involved in close to 100 geothermal-based projects throughout greater New England, including commercial, municipal, and multifamily apartment buildings, with some large residential houses as well. I converted my house from propane heating and traditional air conditioning to geothermal heat pump-based heating and cooling in 2009, and we are saving about $2,000 per year on energy costs. To me, it is energizing each and every day to know that what I design really works. Geothermal systems save the owner significantly on operating costs, drastically reduce the carbon dioxide production, and lessen America's dependence on foreign oil, all things I feel very strongly about. The Norwood Theater project was interesting to me personally for a couple of reasons. The historic nature of the theater and prominence in the town center of Norwood make it a high-profile building with visibility to a lot of people. The fact that the owner, Susan, was interested in the long-term benefits of a geothermal system as a component of the theater's retrofit is impressive. I appreciate the vision that she has in being committed to the benefits of geothermal heating and cooling, even though it is more costly to install than traditional systems and will take a period of years to pay back on the initial investment. Other interesting aspects of the project are the limited size of the site, close proximity to neighbors, and location on the town square. These all provided unique challenges for implementing a geothermal system, making it exciting from a design standpoint. I enjoy challenging projects that cause me to think out of the box. The limited property outside the foundation of the building was the main challenge. The existing building structure is only about 6 feet from the property line on the 2 sides of the building that were viable for placing geothermal wells into the ground. The relatively small area for wells limited the type of geothermal system to the standing column well approach. To compound the challenge, there is an alley only 17 feet wide on one side where wells were needed. That made it very tight to maneuver the drilling rig, which is a 30-foot long specialty truck, and keep the wells on the theater's property. We had to work with a couple of well drilling contractors to find one that had a small enough drilling rig that could place the wells in the alley where they were needed.